Alright, good morning, good afternoon, and welcome again to this video. So today's video, we're going to proceed to our discussion in lesson 3, which is the binomial distribution. So a lot of mathematical experiments often consist of repeated trials, each with only two possible outcomes. It could be success or it could be a failure. For instance, flipping a coin of 10 times results in two outcomes where each trial may result in a head or a tail. We may call the occurrence of a head as a success and the occurrence of a tail as a failure. So experiments of this type are called binomial. Again, please remember when you are talking about binomial experiments, we're talking about here are trials, repeated trials. Okay, the outcomes is only success and also the failure. Please excuse my background. So more formally, a binomial experiment is one that possesses the following characteristics. So if this following characteristics is in the problem, therefore you are going to use the binomial experiment. So first is the experiment consists of n repeated trials. Second, each trial results in two outcomes, which is the success or failure. Okay, only success and failure. The probability of a success, which we denote P, remains constant from trial to trial. The repeated trials are independent. So if a binomial trial can result in a success with a probability P, remember that the probability is P and the failure with probability is Q minus 1. So in getting the success, that it would be equals to P, and the failure is, in getting the probability of the failure is Q is equals to 1 minus P. So then the probability of exactly K, that is the K success in n repeated trials denoted by B, K of n and P is defined as this one. So this nk, we are talking about here combination. Yes, this is the formula of combination, this one. So this is the formula of combination. So we have n factorial over k factorial multiplied to n minus k factorial. So remember that when you are talking about factorial, yes, so let's recall combination is equals to n factorial over k factorial multiplied to n minus k factorial. So when you are talking about example, we have 8 factorial, that is equivalent to 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. So that is 8 factorial. The same thing as 5 factorial, we have 5 times 4 times 3 times 2 times 1. So that's it. So example, a fair coin is tossed 6 times and call heads is success. So call heads is success. So remember the given. So we are going to name all the parts. We need to have the K, the N, and the P, where P is the success, N is the repeated trials, and K is the success. So we have now N. Yeah. And call heads success. Okay. So letter A, the probability that exactly 2 heads occur. So there is an exact that is the K success. Okay. So this would be the clue of our K. So our N is how many times do you toss the coin? So we have 6. The probability of P, which is the, since we're talking about here coin, so we have the head and the tail, so we have 1/2 or 50-50, okay, because there are two outcomes. So 1/2, so that the probability of our success is 1/2, and the probability of a failure, which is Q, is equals to 1 minus P, which is 1 minus 1/2, that is equals to 1/2. Okay, so by this we have the form. We have the K, this is the K, this is the N, and this is the P. So by that, we can now substitute this one. So we have 6. That is, this is not 6 over 2, but this is 6 combination of 2. That's why we have this formula. This is combination again. So 6 factorial over 2 factorial the difference of 6 and 2 factorial. We have 1/2 squared and 1/2 raised to 6 minus 2. Where did we get this 6 minus 2? We have here the formula, which is n minus the k. Okay, so this is the, be careful with substituting your formula. So we have now 6 factorial, 2 factorial. How did we get 4? But that is 4 minus 2, that is 4. Okay, so 1/2 over 2, then 1/2 raised to 6 minus 2. So we have now 6 factorial, so 6 times 4 to 1. And in this, the clue here is you look for the highest, or no, the greatest factorial, so that you can just simply cancel this one. So you can have, this can be equals to 6 times 5 times 4 factorial over 2 factorial and 4 factorial. So you can just simply cancel this one, and then you have just this remaining 6 times 5 and 2 factorial, which is 2 times 1. Okay, so it depends. I hope it's clear to you. So we have now 6 times 5, we have, and 2 times 1. Then okay, so how did we get this 30? That is 6 times 5, 30. 2 times 1 is 2. Then 1/4, that is 2 times 2, that is 4. 2 times 2, yeah. Then how did we get 1 over 16? 1/2 raised to 6 minus 2, that is 4. So by this we have 1/4 times 1/4 times 1/4 times 1/4. Okay, so 1 times 1 is 1, 1. Then 4 times, I know 2, it's 2. I'm sorry, it's 2. That it's 2. So 2, sorry. So 1/2 raised to 4. Again, how did we get 4? That is 6 minus 2, that is 4. So we're going to multiply 1/2 4 times. So 1/2 times 1/2 times 1/2 times 1/2. So 1 times 1, 1. 2 times 2, 4 times 2, 8 times 2, 16. So we have 1 over 16. Okay, so this time we are going to multiply 30 times 1 times 1, that is 30. 2 times 4 times 16, we have 128. So just multiply the numerator. So we have here, how did we get 30? By multiplying 30 times 1 over 2 times 4 times 16. So we have here 30 over 128. So we have, in lowest term, we have 15 over 64. And in decimal, we have 0.23. So the probability of getting at least 4 heads, we have at least, no, that is letter B. So the probability that we can have exactly 2 heads of 4 is 0.23. So this is the probability that we can get exactly, the probability that we can get exactly 2 heads. So we have 0.23.